Welcome to episode 23 of Travelling Science. G'day legends, welcome back to Travelling Science, the podcast that's sharing science with the world. My name's Crowe and I'm the Travelling Scientist coming to you today from my home in Aireys Inlet, Australia. I'm a health science communicator, and on this podcast we interview doctors, researchers and experts, hearing their stories and sharing their ideas that can help us to live smarter, happier and healthier lives. This week's guest is Chloe Kirk, also known as Chloe the Scientist on Instagram, and she's just finishing up her PhD in biochemistry and molecular biology at the University of Miami, while simultaneously getting into a career in patent law. And outside of science, Chloe loves to bake, read, and share her journey in hopes of inspiring more people to pursue a career in STEM. And we'll be talking all about that and more in today's episode, as Chloe answers questions like how she became obsessed with biochemistry, why she's transitioning from science to law, how she got into science communication, why diversity in STEM is so important, what to do if you're interested in becoming a scientist, and what to do if you're already a scientist but you want to make a change. And we'll also discuss things like amyloid proteins, neurodegenerative diseases, patent law, STEM boot camps, Elon Musk, tea versus coffee, baking cakes, and hot yoga. So get ready to be enlightened and inspired by the one and only Chloe Kirk. Chloe Kirk, welcome to Travelling Science.
Thanks so much for having me.
No worries. Thank you so much for taking the time to be here. It's an absolute pleasure speaking with you today. Chloe the Scientist from Instagram. If you don't follow her, check it out because it's super entertaining and inspirational content. Love what you do there.
Thank you so much.
Just to get started, for people that are clicking onto Chloe the Scientist for the first time, do you want to tell people, what did you actually study in university?
Yeah, so my undergrad was molecular biology and legal studies. And so I did quite a few different research projects, but where my heart really fell through undergrad was cell biology, so looking at cells under the microscope. And that's what really led me into my PhD work, where I went to the University of Miami. Official PhD title name is the Biochemistry Molecular Biology Department. But what I really loved doing was cell biology, looking at cells under the microscope.
I remember when I was looking at cells under the microscope at university, and I realized that if you held your phone camera up to the lens, you could actually take a photo of a cell on your phone and chuck it online, and that just blew my mind.
Yeah, other people are able to do that, and I've never, I tried doing that. I've had this Instagram account for 4 years. I could never figure it out. I had other friends that knew how to do it, and I tried myself, and I know you can do it. It is possible. I'm just, I guess, not adept in that sense of Instagram photo taking.
Awesome. So, sorry, continue. You loved cellular biology, and then where did that sort of lead you? Yeah,
so undergrad was, I tried different labs, like I said, and I ended up loving cellular microscopy. My senior thesis, I was working with a big confocal microscope that the building had access to, and frog oocytes. Thought that was the coolest thing ever. We were working with GFP tagged proteins, so you could see them under the microscope.
GFP stands for green fluorescent protein, and it's commonly used in biology experiments because, unlike most microscopic proteins, you can clearly see this one because it lights up fluorescent green. So that's why Chloe was so excited about microscopy during her undergrad.
So that's really where my heart led me. So grad school, I was making sure to look for somewhere I could do what I thought was really cool cell microscope work. My other requirement was I'd worked with different animal models in the past with undergrad. And as valuable as that research is, I myself was not a huge fan of it. So I was very much partial to doing cell work, mammalian cell work specifically. So the lab I ended up joining, chose it because of how cool I thought the research was. We worked with this physiological amyloid called amyloid bodies. And my project through grad school was to understand how this amyloid that you see naturally occurring in cells that's actually beneficial for our cells.
An amyloid is a bunch of proteins that aggregate together, and they're usually associated with things like neurodegenerative diseases and cancers. So people usually think that amyloid is bad. But Chloe's PhD was looking at how amyloid can actually be beneficial for our cells and how we might use that to fight certain diseases. So how can we do that?
We know that it both appears and can disappear again, so disassemble. And one of the big question marks when you're studying amyloids in pathological settings, so that's when you're talking about a lot of neurodegenerative diseases like Alzheimer's disease, Parkinson's disease, they have these amyloids, but they aren't able to disassemble. They aren't able to pull apart again. And so I was using this physiological amyloid to figure out how does it disassemble in the cell, and how can we use those same mechanisms to disassemble those pathological amyloids, like in Alzheimer's disease. And the paper is pending. It should be coming out soon. And it was really cool work. We ended up discovering how that works in mammalian cells and then testing that in our model system of Alzheimer's disease.
That sounds incredible. How does that impact humans? Is that these amyloid proteins, this a big issue for us?
The amyloids that I was studying are something called amyloid bodies, which we classify in this group of physiological amyloids. What that means is typically when you talk about amyloids, you think of big, bad, scary amyloids that you see in diseases. Some of the diseases that you might have heard of before include Alzheimer's disease, where one of the characteristics that you see in Alzheimer's disease is this buildup of a protein in an amyloid form that's called beta amyloid. But this other category, which I hadn't even heard of before I started grad school, which is something I find so exciting about science, there's always something new to discover. These physiological amyloids, they are beneficial for the cells. You see them in naturally occurring things that are going on in our bodies. These amyloid bodies we studied, we saw happen during states of cellular stress. So when our cells get stressed out, I studied heat shock, but other ones you can think of is even, for example, putting yourself in a sauna, or maybe more thinking about diseases again. Your cells get stressed out when cancer is happening, when your cells are rapidly dividing way faster than normal, which is one of the hallmarks of cancer. You see the cells get stressed out, physically stressed out, because there's so much going on. They're dividing so quickly. When these stressors are happening, the cell has this response, which is the amyloid body response, and we see the nucleolus, the very center of our cells, transform into where it normally is able to make ribosomal rRNA to then make ribosomes that then go on to help make new proteins. It stops all of that. It freezes what's going on in the cell and instead creates this amyloid body. So reconfigures the nucleolus into an amyloid body. And I like to think of the amyloid body as this like storage compartment, because when this stress is happening, proteins from all over the cell come to this one central place, the amyloid body, and are put into an amyloid-like fold and are completely sequestered in there. We see cell dormancy happen. The cell is alive, but very much all the big processes that are happening, like normal transcription, translation, are shut down. And then once the stress goes away, so maybe cancer, you're able to kill the cancerous cells, or, you take your cells out of heat shock and put them at a normal temperature again, you see the amyloid body disassemble. And so that was exactly what I studied, is what is going on from after the cell becomes this amyloid body. How does the nucleolus reassemble again and get rid of that amyloid fold?
Wow, that sounds incredible. And so is it quite clear that it's stress that's causing this amyloid formation?
Because most people, when they're looking at amyloids, they're thinking exactly what you and me before grad school were thinking. They're part of diseases, they're bad. But the amyloid fold itself isn't inherently bad. Because I guess if you think of it over evolution, why would our body come up with this system if it's only bad for our bodies? So the amyloid fold, I like to think of it as like a protective state. Because in the cases of, these neurodegenerative diseases, they're kind of taken out of control. But our cells have it for a reason, which is to help protect the proteins that otherwise, if, say, these amyloid bodies, we've done this, if you prevent the synthesis of amyloid bodies but still have that stress happen, the cells get really freaked out and end up dying because there's nothing protecting the proteins that are normally in the amyloid body.
Wow, very cool. Now, since your PhD, you've moved into working in law now. What caused you to make that shift? Yeah,
so it is a pretty big shift, I guess, looking back on it. But in my head, it never seemed like this crazy shift because I'd always been interested in both science and law. I'm going way back to my high school days. I was never initially, I like science as the science ideas, but the practicalities, looking at science in a textbook, I was never really excited by that. And I went to a high school. It was called a classical high school. Sounds quite odd. I know not many people have heard of this, but it was one that was designed around like learning logic and Latin. So I learned Latin for 7 years. We did rhetoric. We did like mock trial and debate. It was really focused around like humanities, and honestly, it seems like the first year of law school almost now, talking to lawyers. And that was kind of the foundation of what I had during high school. So I thought that law was also, I was thinking like law or business. And science wasn't, it was kind of like an afterthought, like learning about CRISPR, gene editing stuff was cool, but I didn't want to take the multiple choice test on it. And then it was my senior year of high school when I got the opportunity to volunteer in a research lab. Very part-time. It was a couple hours a week at a local, the University of Minnesota, a cancer biology lab there. And like I say, it was mainly just following around graduate students, making solutions, learning what the heck, genes are, and how you can put those into cells, that kind of stuff. But it was so cool getting to see the stuff that I'd read about in textbooks actually applied to the real world and how they were using that to help fight cancer. And that really changed my direction. I'd been applying to undergrad, at that time. And I'd been putting, I had like law school or legal something in my essays. I changed all of that to science. And I'm going to University of Wisconsin-Madison for that. But I still had that back of, I liked the law. I liked the legal side of everything. So during undergrad, in addition to doing my science classes and research, I did a second major in pre-law or legal studies is what we called it. And obviously, eventually my love for science went out, which is why I went to grad school. But it kind of felt like the perfect joining of both worlds when I learned about patent law, which is pretty late on. I only learned about it in the past year of grad school. That, wow, I can combine both my interests back together again. So that's kind of the weaving story of how I ended up back in law.
There you go. So it was almost like you were planning to become a lawyer and then you kind of just got dragged into the world of science and went the other way.
Yeah, kind of, yeah. I mean, because I was so young back then, right? Like 16, 17, 18.
Nobody even knows what they want to do at that age anyway. Yeah.
Exactly, yeah. Like, how are you meant to pick your major, when you know so little about what the world is? Like, if you tried to explain patent law to me as a high schooler, I'd be like, what are you talking about? I either knew about, like, bench research or, going to be a lawyer in court. I didn't realize there were so many different avenues within that, which I think is really awesome.
There's really a spectrum of jobs throughout. While we're on that topic, would you like to maybe just give a brief indication of what is patent law for someone who, like myself, who might have very little, no idea? Yeah,
so like I said, I didn't know much about it either until it was my third year of grad school. I was trying to find ways to combine my love of science with law. And I knew I didn't really want to work in bench science anymore. And so I was like, how can I put those both together? And I talked to, who did I talk to? I don't even remember. I ended up talking to someone who connected me with the Technology Transfer Office, which most universities have something called a tech transfer or technology transfer office. What that office is there for is if any professor wants to has some really cool research and thinks that someone else might be interested in it, they can apply for a patent. And so they do that through the Tech Transfer Office. And when I was there, I learned what a patent actually is. The definition of patent is to protect someone's intellectual property, right? So if you come up with this really cool new mechanism for fighting cancer, and you want to make sure that no one else tries to steal that from you and then make a bunch of money or start their own company, and it's your own idea, you can go ahead and file for a patent, claiming whatever that intellectual property is. And so both that's beneficial for the inventor because it makes sure that no one else can take that idea away from you. But it's also really beneficial for the rest of the world because by documenting that innovation, there's a certain period of time that you can have exclusive limits to no one else being able to do that technology. But after that certain limit is up, anyone else can use it. And they've got the specific manual or the patent on how to do that technology. And so being in patent law, you get to work firsthand with those really cool inventions. And that was what really drew me to the field, is getting to be at the forefront of those cool inventions, not necessarily having to do the experiments and the troubleshooting myself, but getting to see the hard work, the fruits of the labor, and then helping them both document it and then make sure that information is available for other people.
Very cool. You get to be on the cutting edge research. And an example of that I like to think about all the time is paracetamol, for example, or acetaminophen. That drug, once upon a time, was under patent, I'm sure, and might have been quite expensive. But once it came out of patent, other companies could make it, and now you can get these medications for $1 or a couple of dollars.
Yeah, no, precisely. And that is one of the controversies with with all of the drug stuff going on. Why you hear of generic drugs is because the first X number of years that companies got an exclusive license to it, but then after that license is up, anyone can make it. That's when you get the generic drugs.
Exactly. Cool. That sounds super exciting. So I wonder if you have any plans, or you're still trying to figure it out, but what do you sort of hope to achieve once you're an expert scientist and expert in patent law? What are your goals and ambitions?
That's a great question. I'm still sorting that out because I am a month into this job. So brand new. It is very much like learning an entirely new field, because you're going from how all of grad school, you learn how to write scientifically, which is often you're writing a lot of words. And then in law, you want to do the exact opposite of that. And you also want to be it's almost formulaic, because you want to make sure you're writing, exactly how previous people have written. So it's all very standard and uniform, which I love. But that being said, I am quite interested in going back to law school. It isn't a requirement by any means to be in patent law. So currently I'm what's considered a patent law clerk, or other companies call it a technical specialist. It's a pretty temporary role, because the idea is they create this for people coming out of science or STEM backgrounds like myself, wanting to enter the world of law, but not having any or much background in it. The next stage is, at least in the United States, is to take something called the patent bar, which is completely separate from any other, bar or exam that you might think of with law. Because this is exclusively for people with STEM backgrounds, so science, technology, engineering, mathematics. You have to have at least a bachelor's of it, or there's some exceptions there, but essentially a background in that STEM field to sit for the patent bar. You do not need law school, law degree, law bar, any of that. And so that's what I plan on studying for next. It is meant to be a very tough test. Typically people spend like 6 months studying for it, and it's only got like a 50% pass rate. And mind you, these are all people with STEM backgrounds taking it. So I've been told by my firm that it might take a couple times. But once you do that and you pass, you become a patent agent. And that is a career in its own right. You can do patents for the rest of your life. You sign off for the patent bar, you're good to go. So I definitely plan on doing that. But then the optional part is going back to law school. So then you become a patent attorney at the end of all that. And the advantages there are, so as a patent agent, you're getting to sign off on the patent front, but you still have to have an attorney sign off for the legal side. And so as a patent attorney, you can essentially do both. But yeah, so the plan is the patent bar to become a patent agent, and then law school. I'll be doing law school. Typically, people think of law school as, the 3 years during the day. There's another option that's becoming increasingly common, which is night law school. So you work during the day and then you go to law school at night. And fortunately, being in Washington, D.C., where there are a lot of law schools, there's quite a few options for night law school classes.
Very cool. It sounds intense, working a day, studying at night. And also that test that you have to do with the 50% pass rate, it's going to be tricky, but I have faith in you.
I like a challenge, Otherwise, I wouldn't have done grad school, right?
Totally. And I feel like education is always good. So going back to law school and studying, and just the more you learn, the more you know, it's always going to add to your future, I'm sure.
Yeah, I completely agree with you that I never want to take education for granted. I remember I did a little bit in high school because I was like, you just take these tests, et cetera, et cetera. But now there's you can stop learning whenever you want if you don't have tests anymore. And I'm trying to make sure I don't take education for granted. So I completely agree.
You talked a little bit about STEM there, and I know that something you advocate for quite a lot online is diversity in STEM, or diversity in science. I wonder if you wanted to talk a little bit about that.
Yeah, so I mean, as you mentioned, diversity in STEM is absolutely paramount. I mean, just think about when you think of the word scientist, who do you think of?
Old white man, yeah.
Precisely. You think of an Einstein-like older white man in a lab coat. And that's pretty standard. And for sure, the field is changing. Like my grad school, my department was more women than men in as PhD students. But if you still look at the people that are higher up in, academia, but also in industry, you're seeing a lot more men than women, especially, white men than any other sort of race and women. So I'm a huge advocate of getting more people into the world of STEM. So science specifically, of course, but any of the technology, the coding, the mathematics, because there's so many different ideas that can be gleaned from the different backgrounds, different perspectives that are coming from the non-traditional scientists that you might think of. And having those different viewpoints is paramount to being able to push scientific discoveries forward. That's one very important part. But the other important part is it's hard to see yourself in a field if you don't see others like yourself in it. When I was in grad school, we ran every semester a high school field trip where we take from one of the public high schools of Miami-Dade County, which is historically underrepresented communities. We bring them to come for a day of learning what it's like to be a scientist in a research setting. What we've done is we have different experiment booths set up. The latest one we even did was like a crime scene investigation, which I thought was super cool. So you had to solve a murder throughout the different activities you had. But the idea was to show what we got back from a lot of the high schoolers is, wow, there's one, really cool things you can do with science that I never saw out of the textbook. And two, there's so many different types of people doing science rather than what I see on TV. And that was so amazing to hear. And that you don't need to be this, perfect genius or fit into all those different boxes that you think of as a stereotype for a scientist or an engineer in order to pursue a career that you're interested in.
Absolutely. I think that is super important. I was speaking with Dr. Aaron Dingle last week from the University of Wisconsin in Madison. He basically said that his work was inspired. He works on creating artificial limbs, and his work was inspired from watching Star Wars back in the day and seeing Luke Skywalker get a prosthetic robotic hand, and that's basically what he's creating now. But one of the things that he said, that diversity in conversation is super important, and he basically said, go out there and just have cool conversations with cool people. Doesn't have to be other scientists, but just anyone. Talk to as many people as possible. The ideas that can come together are just mind-blowing. There's so much potential for having diversity in the world of science and in conversations.
Yeah, exactly. I always like to think or say when I'm talking about science in the world of academia and research that we see ourselves, and I saw this in grad school so much, we're on this ivory tower where we think what we're doing is, paramount importance, and it is, it's really cool. But we're writing it and discussing it in a way that 5 other people maybe, if that, can properly understand. And what you go back to, these conversations that you need to have. And I would say, I would actually encourage it to be not with scientists, because those are some of the best conversations I've had when you're talking about science with someone who isn't actively studying science research. They might think, okay, I'm not going to understand what you're talking about at all. But you can, because it's just what the world around us is, right? You can all understand it. It's just how scientists choose to explain it to everyone else. And so, yeah, just going back to what you said about conversations, I think that's one of the most important things you can do as a scientist, or anyone with a science background at all, or STEM background, is putting yourself out there to communicate and talk about science, to remove the barriers and the hurdles that people see in science.
Yeah, that ivory tower that you were talking about, if we're writing science in such a way that it can only be read by other scientists, and even then not all scientists can understand what you're writing about, it just doesn't work. So we do definitely, I think there is a need for better science communication and more science communication, which is exactly what we're both trying to do. But I wonder if there is a better solution, or I wonder what else we can do to improve, break down those barriers and improve science communication with the world.
I would say that one thing for sure is what we're doing now, just on a bigger scale with everyone getting involved. Like the amount, especially over COVID, the amount of people who started getting involved in science communication, just, Instagram, TikTok, podcasts, the barriers of getting to this, especially the next generation, the people that could become future scientists, engineers, mathematicians one day, we're able to get to them with a click of a button now. And so I think just having more content out there that they're able to find is what is maybe what you're saying is how we can spread it even further, getting that science communication out there more.
True. Very true. Who inspires you to do what you do? Do you have any people you look up to?
First and foremost, it would definitely be my parents, though. Just both of them have science backgrounds, biochemistry backgrounds. And I never fully appreciated how much that would impact my career. Because like I said, in high school, I was like, no science, everything law, business. And then here I am studying biochemistry. And I know somewhere back in the ways, me even thinking that science could be an option is due to my parents being biochemists. And this all goes back to the importance of breaking barriers and diversity in STEM, because just by me having the opportunity to know that exists as an option is what so many people don't have. And I'm sorry, I'm tying so many things back together, but like science communication is how you can show more people who might not have parents that are scientists. They're able to see, whoa, that science experiment is super cool. Whoa, that engineer is talking about this really cool thing I'd never thought about before. And getting to inspire other people to talk about that stuff. So first and foremost, my parents answered that as a role model. But
thank you, Chloe's parents.
Yes, thank you, my parents. I would say another one I remember in high school is Jennifer Doudna. So the CRISPR-Cas9 gene editing story. Jennifer Doudna is one of the huge people that is involved in the CRISPR. And so actually my high school senior project, after working at cancer biology or volunteering at the cancer biology lab, they were working on CRISPR. And that got me really interested. I did like a whole deep dive research on the future of CRISPR, gene editing and the ethics of it. And so my senior thesis was all about CRISPR and how it can be regulated and should be regulated. And through that, I learned about Jennifer Doudna, who is one of the discoverers of it. She actually shares a patent on that. So I loved her research. That was like really cool, getting to see a woman in science, at the forefront of science, getting to do all of that. So definitely one of my role models for science research. And then my third, and I'd say really big role model in terms of getting involved in science outreach and communication, science education broadly, was in undergrad, I worked for this department called WIS Science at the University of Wisconsin-Madison, specifically with a woman named Jeree Bryant. Her background, she had a PhD in science, but she decided to come work for this department called WIS Science. The whole idea of it was to promote getting diverse groups of students in STEM to the University of Wisconsin-Madison, and to help them excel in STEM degrees. Because again, going back to that whole idea of if your parents are scientists, or you grow up going to science museums, introduced to all the terminology and taking those AP science classes, or sorry, that's an American word, advanced placement classes for science and math. Of course, you're going to have a better leg up when you get into undergrad, because you would have already known these different terms, versus someone who hasn't experienced that before. It's going to be a lot bigger learning curve. This department was there, one, to encourage people to go into STEM, and then two, helping retain those people to finish with STEM degrees. They had a yearly, they called it a STEM boot camp, where the people that were involved, you got to come in a week early, and you got to do a STEM boot camp. You'd learn how classes were taught, you'd learn specific science terminology, and you just get to meet other people that were interested in the same stuff as you. I went through that myself as a participant, and then I was one of the leaders, so then they'd hire people back in to come and lead the groups of these new students. Then I helped run that the following year. Through all of this, I got to work closely with a woman named Jeree Bryant. She pushed for anything we wanted to do in terms of science education and outreach. She was there for it. We ran some really cool workshops through the library, trying to connect people with different sorts of science careers and science majors they might have not heard about. And sorry, it's gotten a bit of a tangent about science outreach stuff now, but she was really instrumental for me in creating my science Instagram account at all, because once I got to grad school, completely different university, other end of the country in Florida, they didn't have anything like with science. They didn't have anything to motivate people to, one, go to STEM and to stay in STEM. And so Instagram was first my way to just start dabbling back into that, just sharing my experiences and trying to motivate other people to consider a STEM career. And then two, gave me kind of going forward into the science field trips and the bigger science outreach efforts I was able to do.
Incredible. And so it sounds like you probably wouldn't be here now without her. So, and it's people like that that are helping get young people into STEM and science and just help them, you know, learn whatever they want to learn and do whatever they want to do. It's people like that that, you know, just they have such a big impact on young scientists without even maybe realizing. And another thing I think is that we definitely need more STEM boot camps and that sort of thing, those programs to sort of motivate people to really get into it and sort of launch their studies and their careers in that sort of trajectory. I think we need more of those programs.
Without a doubt. I mean, I got really lucky with my undergrad, my freshman year when I did that STEM boot camp myself. We were all even put in the same dorm together. So it was like I think it was called Bio House. So the whole floor of everyone living in university, we were all science, engineering sort of people. And at the time, I just took that for granted. Again, realizing hindsight, how valuable it was you were taking the same bio classes, chemistry classes, organic chemistry classes with these people in your hall. Whenever I had a question, I could just go to our common lounge and find someone else working on it and be able to troubleshoot with them. Finding study partners that way, being able to problem solve things. And that was something that was really beneficial. Even STEM bootcamp, you find other people that, one, are interested in what you're doing in, but also are able to help you be able to graduate with that, whatever degree you're interested in pursuing.
Chloe, what do you do when you're not in the lab? What do you do for fun?
Well, one big thing, I don't actually know if you can see in the Zoom behind me, but baking. I love to bake. The kitchen, why I'm saying behind me is because the kitchen's a bit of a state at the minute. I've tried to tilt the camera away because I've been baking all day.
What did you make?
Maybe isn't so surprising, you know, if you like science and research, you like baking too. I love baking, like watching the British Bake Off, for example. I'm trying new recipes. I've started doing more cooking now. Like, I've always cooked, but now I'm like trying new cooking recipes because I used to bring my sweets into the lab all the time, but now I don't have lab mates to bring them to. I can't just keep cooking cakes over and over again because there's nowhere for them to go.
Yeah. And then you gain like 10 kilos and you're like, what have I done?
Exactly. I made a chocolate log last week and it looked atrocious, but it tasted amazing. And me and my boyfriend, we were like, there's no way we're going to eat all of it. It tasted delicious, but it looked like a turd, for lack of better word.
It sounds atrocious, but I'm sure it was good.
Yeah, it was bad. But we managed to eat it in one day. I had a stomachache the next day, but it was, yeah. So anyway, so all to say, baking and a bit of cooking because I need to eat a bit healthier as well. That's the main one for sure.
I also really love baking, and I think that's definitely something that a lot of scientists seem to do. I often ask the question, what would you do if you weren't a scientist? Most people are like, probably chef or a baker or something.
That's so true, though.
Oh, I know.
Have you seen those memes of the like, if I wasn't in grad school, I'd open a bakery kind of thing?
No, but I should get into that. In fact, maybe that's a niche right there. Scientists becoming bakers. But no, I like baking as well. And I made a brownie yesterday to take to my friends at work. And when I was flipping it out of the tray, I dropped it.
No!
On the bench, it kind of got messed up. But I pulled it back together and nobody knows. It still tasted great.
Well, that's all right. You're not on the Bake Off, right? It's not going to be presented to Paul Hollywood.
Yeah, totally. Do you have any daily rituals that you swear by? Anything that helps you get through your day in the lab or day in the law office?
I mean, without a doubt, tea. I think this goes back to my British roots. I grew up drinking a lot of tea. So one of the first things I had to get from my office in law was my aunt sent me a tea kettle because my floor of my office, they do have like a hot water spout.
It's never quite the same. It's not hot enough.
It was fine. My problem more was because I was getting up once an hour to go refill my tea. So everyone in the office would one see that. And then two, I was carrying it back, spilling it a little bit along the way. So it's been a game changer having that tea kettle in the office. But yeah, so other than tea, I try to wake up early. It used to be better in grad school. I'm still trying to get back into a bit of a routine. But waking up early definitely helps a lot. So I've got some time for myself before I have to get into the day. And the one that I've been getting back into that I used to love back when I lived in other cold weather, Wisconsin, Minnesota, was hot yoga. Have you ever tried it?
Love yoga. I hate the heat. So no, I've never tried hot yoga. But again, if you recommend it, I will try it. But I don't think I'll enjoy it.
Really? Okay. Well, no, if you hate the heat, you will hate it. But I loved it in Minnesota and Wisconsin, again here, because when it gets cold, that's how I go to a 6:15 a.m. class. And so it's I roll out of bed at 5:30 in the morning, but it's great because I can go and just lay in 105-degree Fahrenheit temperature for an hour. And I feel like it loosens my joints so much more doing it in hot yoga. I did it yesterday and I'm properly sore today. All my body, it feels like I've done a big workout, which I guess I did. It was a lot of stretching and stuff, but I didn't do it in Miami, of course, because it felt a little bit redundant if I'm already in 85, 90-degree Fahrenheit. If I wanted to do hot yoga, I could just go out on my balcony,
It's just yoga there.
Yeah.
I think I would prefer cold yoga. And then you could just call it froyo, which is a good name.
Yeah. Not my cup of tea, that, but...
I love that you said tea, though, because most scientists go and say coffee, and I love tea. I drink tea all the time, so good on you. Jumping on the tea train.
You don't drink any coffee?
Maybe once a week. I will have a shot just because.
I'm the same way. I do espresso. Love the smell of coffee. And then I try regular coffee and I hated the taste. It's this is disgusting. And then I don't know why. Suddenly espresso, because it concentrates the what I smell, I guess. I don't know. I'm obsessed. But like you said, I don't want to get addicted to caffeine. So I try to limit myself to the caffeine of tea and save the espresso for a once in a while occasion.
If you really need it, if you really need to study hard. You read and review a lot of books online, and I was just wondering if you have any recommendations, some of the best books you've read that you want to share with us.
So actually, I'm so glad you asked that. Where's the book? Sorry, I'll just say it's the Elon Musk book. Preface, I'm not a huge Elon Musk fan. I've never I knew what he'd been doing, but I'd never been oh my gosh, he's my idol or anything. And the book is written by Walter Isaacson. He's a very famous biographer. He's written one on Jennifer Doudna about CRISPR. He wrote one about Steve Jobs. He's also written one on Albert Einstein, Leonardo da Vinci. But anyway, he followed Elon Musk for the past X number of years and followed his story. And it came out, last month or two? I was actually my boyfriend who really wanted to read it. And I was I really love the biographer, Walter Isaacson, but I don't really know much about Elon Musk. But anyway, he got it. I was okay, I'll start it. It's this huge book. It's 600 pages. So I thought it'd be a slow read. Oh my gosh. I mean, that's what I was reading this morning. I have such a hard time putting it down. I'm obsessed. It's not I love Elon Musk after reading this, but it's such an amazing... Walter Isaacson's so good at writing with the mind of someone. You can understand so much more of the creative decision processes. And because Elon Musk has shaped so much of what's been going on the past 5-10 years, Tesla, SpaceX, Twitter, now X, it's such a timely read too to understand everything that's been going on. And not only that, because we've seen it in the news for the past 5 years, but this has been going on for works for 10, 20 years, back when he was doing PayPal. So that would be one of my all-time, I still haven't finished it, but definitely top book rec of the year. Obsessed.
I read an Elon Musk book, but not this one. I read one a few years ago. So obviously there is a new one out.
I know the one you're talking about. I haven't read that one.
It was good. It's good to get a brief history of Elon Musk, but I feel like this one from Walter Isaacson is probably the way to go. If you want to learn about what Elon Musk is up to and why he is the way he is and some of the incredible stuff that he has done, probably an incredible read. Any other book recommendations before we move on?
I just finished The Song of the Cell. That was phenomenal.
The Song of the Cell by Siddhartha Mukherjee is a book that came out just last year, and it won several awards, including Book of the Year by The Economist. And it tells a vivid and suspenseful story that spans from the discovery of cells over 300 years ago to our current understanding in the modern day and the age of creating new humans. Phenomenal book. Read it now. Dr. Mukherjee is a literary genius. I actually reached out to him. I read that book as well, and I reached out to him to see if he wanted to come on the podcast. Obviously, busy man. He hasn't responded, but he still might. You never know.
Yeah, no, that'd be awesome. I mean, his writing is so well done. But I love how he writes not only just about the science, but like the story of the person who made the science, because it really like drags you into the story better, you know?
Mm-hmm. Yeah, I think storytelling and science put together is a beautiful combination, and if more people could write those sorts of stories, I think science communication will blow up.
Precisely. Actually, now speaking of another, now I'm thinking of another book I just read that, or a few months ago. It's called For Blood and Money. So this one's more about biotech and how they took this idea and made it into a cancer therapeutic. And that, again, why it's so good is because it's written as a story. I think I read that book in a weekend. It's a nonfiction, completely like it's a biographer writing about the story of this company, Vertex, and yeah, it's phenomenal. So like what you said about the storytelling element of getting people hooked on it.
Yeah, love that. Incredible. Chloe, I've got a few listener questions here for you, if you've got a moment to answer those.
Yes, please.
But before that, each week here on Travelling Science, we make a donation to a charity of the guest's choosing. And this week, Chloe has chosen to make a donation to Skype a Scientist, a non-for-profit group that enables scientists to contact and educate students around the globe. So a donation has been made to Skype a Scientist on behalf of Chloe Kirk. And if you'd like to make a donation as well, that would just be incredible. The link is in the show notes just down below. But for now, back to Travelling Science. So the first question is from Natsuki Footy Mason, and she was wondering if you have any advice for an aspiring biochemist.
That's a great question. I think the first is not to get daunted by test taking and what you're learning about in class and the scores necessarily that you're getting on exams. I was never someone who was scoring the top in my exam classes. I was always the one going to tutoring, chatting with friends how they did stuff. You do not need to be the smartest person in the room to follow biochemistry or really any of the STEM disciplines. 99% of it is just passion, because especially if you go into research, very few things are going to work on your first time. And so you can't expect to be a perfectionist and the best person in your class. What you really need is that bit of grit, that bit of perseverance, that you're willing to troubleshoot and try again and try again and try again. So I'd say that'd be probably the most important thing, is just the perseverance aspect of it.
Definitely. And I think adding on to that, like you said, 99% is passion. But I think that passion grows with time as well, as you start to get into it and learn more of the intricate details and keep trying and maybe failing and trying again and trying something a bit different. That passion will grow and you'll start to love or realize you hate it. But, it can go either way. You don't have to be crazy about biochemistry before you get involved in it. You can try it out and you might find that you grow to love it even more with time. Sorry to jump in there.
I love that you mentioned that, because I remember when I was looking at grad school and applying to grad school, it was this huge daunting task, because they ask you, what your interests are. And you're meant to pick a lab that you're going to work on this project that's going to become your baby. It's going to become your entire life. And that was scary. Like, how the heck? I don't know. Like, I know cancer is a thing, but that's it. How am I meant to pick a specific gene I'm going to work on? And so what you say about a lot of it grows as you're going. I picked the lab. I chose a couple things I really liked, and microscopy was one of them. And that was how I honed in on picking the research lab I did. But if you'd asked me 4 years ago if I would have fallen in love with these things called amyloid bodies and the different proteins that have disassembled, I'd be like, no. And now here I am. I think if you get me talking about this, I'm not going to shut up for another 30 minutes. So what you said, passion is everything, and it will grow as you work on it.
Totally. So there you go, Natsuki. Another question here from Kirillina is actually kind of the opposite. She was wondering if you have any advice for someone who is a scientist but doesn't enjoy research or isn't really enjoying the lab. What would you do in that sort of situation?
No, that's such a great question, because I think you can love biochemistry but not love research. I still think research is really cool, but it's not for everyone. I think it's valuable to try it, and it's valuable to learn what you do and don't like about it. And that can really help guide what you want to do in terms of a science or STEM career. Because something that really is not talked about enough, and I'm glad we're both, the platform in general of science communication is talking more about this, is the different types of careers you can do with STEM. So being worried you're not going to like research by going to science don't worry about that at all, because there's a million different things you can do with that experience of your science research. To name a few, one, science communication is an amazing way to do it. You've learned how to talk and think about scientific topics. Now you communicate it to the rest of the world. You can go work for a biotech or pharmaceutical company or life sciences company, but not work at the bench. So you could be doing marketing, you could be doing sales, you could be doing so many things that are involving science without doing the science yourself. You could do patent law, like what I'm doing, if you're really interested in the legal side of science. Becoming a teacher is another amazing one. That's actually way down the line, I'm hoping. I've got so many things I'd like to do, but I'm hoping one day, maybe when I retire, I'd like to become a high school science teacher or something. It'd be a lot of fun. But there's so many ways to combine your science. Or say if you're I don't want to touch science again. I hate not just research, but science. I hope not. But if that case, you become really jaded by it all, the analytical and critical thinking skills you've learned from your time doing research are invaluable. No matter where you go, you're able to take that skill set and transfer it anywhere. You could go into fashion, retail, completely non-science related business. And you've learned how to, sift through literature, problem solve, be able to articulate your ideas correctly. Those are things that people don't realize are the core skills you get out of grad school, not how to pipette.
Totally. They are adaptable skills. And if you go to a lot of places with a resume saying you're a scientist, they're probably like, oh my God, hire that person.
Precisely, yeah.
Seems like there are a lot of options out there. For any scientists that are not vibing being in the lab, there are options out there for you. Don't stress. And maybe to harken back to what we were talking about before, it might be important to be having lots of diverse conversations with lots of different people. You never know where you might end up.
Actually, I'm so glad you brought that, because that's how I learned patent law existed. That's how I learned that non-academic or industry jobs existed, is just by talking to people that aren't in the academic bubble. And how I did this sounds scary, but I promise people are really nice about it. Just reaching out to people on LinkedIn or who you see on social media, and just say hey, I'm a grad student, or hey, I'm a student, or hey, I'm doing research in this and I'm not interested in this anymore. Could I chat with you about XYZ because it sounds interesting? The amount you learn from those type of conversations, you'll learn about career paths that you didn't realize existed. And often they can help you, navigate your way. They might be like, oh, you might want to check out these companies because they might be hiring, or, this government job.
There you go, Kirillina. Good luck to you. And one more listener question from D. Jones. We just wanted to know, what's harder, studying science or studying law? Any thoughts there?
Ooh, that's a really good question. I think it depends a lot on how your brain works, just kind of how you think about things. I think law comes a bit more easily to me. That might also be because that's, again, my high school training was definitely more focused on how to think in a law way. So learning the science and how you think about research was just a new way I needed to learn. So I say inherently for myself, it would be that law was a little bit easier. That being said, though, doing a complete career jump from science to law, I know absolutely nothing at the minute. When I'm writing everything, it comes back in red line, So it's neither are easy. I feel like it goes back to whatever your passions are. That if you're passionate about something and you enjoy learning about it, you'll be able to sort your way through it.
There you go, D. Jones. Thank you so much for answering those listener questions, Chloe. And just to finish off, I've got a lightning round, if you're ready.
All right. I'm ready. Let's do it.
First question, I've seen on your website that you love traveling. What's your favorite country that you visited?
Japan, by far. I did an internship there for 6 months at a biotech in undergrad, and it was tough because I was such a picky eater beforehand. And I fell in love with the country. I hope to be able to go back soon.
Yeah, I went to Japan. This time last year, I was in Japan. Awesome country. If you could do something completely different with your life, if you weren't into science or law, what do you think you might have done?
We talked about this already, but baking. I would 100% open like a bake shop, maybe like a bakery and a bookshop. Oh, that'd be great, actually. And then maybe have like an option for Prosecco or something in the evening. Oh, that's amazing. Yeah, that.
Look, that's still an option, and I look forward to visiting you when you open that shop up.
Now you're making me think I want to do this.
What do you love most about science?
I love all the unknowns. I remember thinking in high school that everything was known because it's in textbooks, right? And then going into a research lab, you're like, wait, we know nothing compared to what's actually going on. That's what I really love, is that every day there's so much going on. You can always be learning about new things, new topics, and you'll never know everything.
Totally. What do you hate about science? What's the worst part?
How academic papers are written. I think academic papers should be written much more for the lay audience. I know there's an argument with, oh, well, you can't get into as complex details. But at the very least, you can have, some papers are even doing this now, like science, essentially where they have like the first page and you can talk about like, it gives like a general overview of what it is without talking about the statistical significance of, gamma protein XYZ. And so it's much more easy to digest while still conveying all the important information that was made from that discovery.
It's kind of like the TLDR of the research paper.
Yeah. And again, some bigger journals are starting to do that more, but I think that should be required as a basis for if you're sending it to any publication, you should have to have that as like the abstract, but an abstract that anyone could understand.
Totally. If you had an unlimited budget, well, that's a bit much. If you had $1 million budget, what type of research would you want to be focusing on? Where would you want to put that money?
Oh, that's tough. Well, because right now, because I'm just coming out of grad school, I would 100% say the exact research I was working on, right? So understanding amyloid proteins and how you can affect pathological amyloid disassembly. But another one that's always been near and dear to my heart is I think cancer research is super exciting. There's so much you can do on that. But I think I need a bigger budget than $1 million to do that with how much is going on there. So I'd probably say the current research I'm doing now, just spend more money on it.
Sounds good. And do you have a favorite thing to bake? What's your favorite thing?
Oh, that's so tough. This one might be the toughest question, actually. Focaccia. I've been loving to bake focaccia. I actually just made one this morning.
Love a good focaccia.
That might be my favorite thing. Yeah, but then I'm such a chocolate person. Double chocolate banana bread is a recipe. I promise this isn't sponsored. Smitten Kitchen is the best double chocolate banana bread recipe. Like, I swear by it. It's like a chocolate cake, but banana.
I have like 5 spotty bananas in the fruit bowl right now. I'm going to go cook one later today. I'm super excited, but I'm going to need that recipe. Okay, so here's what you do. Go and buy a big bunch of bananas, more than you can eat, and leave them out on the kitchen table for like a week. And when they start to go all brown and spotty, go get yourself some chocolate, flour, eggs, butter, cocoa, and then Google the double choc banana bread recipe from Smitten Kitchen. This cake or bread will actually change your life. I made it, I inhaled it, and now I'll probably never make regular banana bread ever again. What's the point? Incredible, Chloe. Well, it's been an absolute pleasure speaking with you. Thank you so much for taking the time to come on the show today. It sounds like the research that you've been doing in the world of neurodegenerative diseases and cancers with the amyloid proteins, and now you're moving into patent law, which is just outstanding, and I'm really excited to hear more about your work in the future. But yes, thank you so much for coming and chatting today all about science and science communication.
Yeah, no, thank you. I was super excited to be on this. Thanks so much for offering. I think what you're doing is super important. Like what we've been alluding to, science communication is, that's how you get more people in science, is being able to talk about it more and see and hear what people doing science, engineering, etc. are like. So I think this is really valuable. Thanks so much for having me.
Yeah, and obviously we want to get more people involved in science and understanding science so we can improve the world in some way. That's the goal here. And in keeping with that theme and everything we've talked about today, I wonder if you've got one final piece of advice that you'd like to share with our listeners, something that they can take home and act on to improve their lives in some way.
I think mine would probably be always be open to learning. Like I've been reading a lot of science nonfiction now, and I really enjoy it. But it's when I started grad school, that was more of a like forcing myself to start learning about other types of science going on. But by forcing myself to try these new things and keep on learning, I mean, you start to enjoy it all. So I think that you should never stop enjoying learning, and you should always be trying to push yourself to learn more and as much as you can. And with today's technology, you've got it all at your fingertips.
So there you have it, legends. That was Chloe Kirk, biochemist, patent law clerk, and baking expert. And I actually had a ball chatting with Chloe. I apologize I couldn't make this episode shorter. She just had so much knowledge and enthusiasm to share. But one thing I'd like to go back to was Chloe's passion for more diversity in STEM. See, you might think that the worlds of science, technology, engineering, and mathematics are overrun with white males. People like me. We suck. But it doesn't matter what gender you are, what ethnicity you are, what age or ability you are. There are plenty of opportunities in STEM for everybody and anybody who's willing to get involved to help make the world a better place. Don't be discouraged or intimidated. If you think you might have a passion or even a curiosity for science, get involved and don't let anybody tell you that you can't do it. And for more inspiration, follow Chloe the Scientist on Instagram or check out chloeckirk.com. Links are in the show notes below. And make sure you subscribe for more Travelling Science every single week. Follow Travelling Science on Instagram to see who we're interviewing next, and there you can send in your listener questions. And if you're more visually oriented, feel free to check out the Travelling Scientist YouTube channel. Finally, if you stick around to the end of the episode, I always leave you with a little secret. And this week's secret is that I think it's time for the Travelling Scientist to travel again. This time last year I was in Japan, I went to Canada a few months back, but now I'm thinking of exploring some new countries like India, Sri Lanka, and the continent of South America, which is super exciting. I'm just in the planning phase at this stage, but I'll keep you updated. And if you've been to any of those places that I'm thinking about going, send me some advice, reach out and say hi. I'd love to hear from you. Anyway, thanks so much for listening, legends. I appreciate you and look forward to bringing you all of the science in 2024. Catch you all next Science Sunday. Cheers.